There we go. Okay, this is number 10 on lesson 6.5. Here's the problem. It's on page 330 in your books. The average teacher's salary in New Jersey, it says ranked first among states, is $52,174. Suppose that the distribution is normal with a standard deviation of $7,500. What is the probability that a randomly selected teacher, they're talking about one teacher, makes less than $50,000 a year? So on part A of this problem, we're going to assume that the salaries of individual teachers is normally distributed. So we're going to use a normal curve. It tells us that the average teacher salary in New Jersey is $52,174. It also tells us the standard deviation is $7,500. The key here is that they're talking about individual teachers. So each value along this horizontal axis is a value of x. All right? If we're talking about individual teachers, we call this horizontal axis x. We're going to transform those into z-scores. And what's the probability that a randomly selected teacher makes less than $50,000 a year? So 50,000 is below the mean, so I'll put 50,000 over here to the left. Since that's an individual teacher salary, we're going to call that x. Do I want to find the area to the left of that line or to the right of that line? Left, because it says less than. Less than would be to the left on a number line. So I'm trying to find that area. So really, this is really review. This first part is really review from lesson 6.4. So I find the z-score for 50,000. I've got two different formulas. Now that we're on 6.5, there's two different formulas. Do you think I use the top z-score formula or the bottom one? The top one, because we're talking about individual teachers' salaries. So, and that's the one that uses x. So we'll plug in our x value of 50,000 minus the mean, which is 52,174, divided by the standard deviation, which is 7,500. That'll give us our z-score for one individual teacher that makes $50,000 a year. And if my notes are right, that comes out to negative 0.2898666. So we'll round that to negative 0.29. Always round your z-scores to the nearest hundredth. So that negative 0.29, that means that a teacher making $50,000 a year is that salary is 0.29 standard deviations below the mean. Any questions about that? Okay, so now we go to our z-chart and look up that score of 0.29. Ignore the negative. 0.2 and 0.09. We look across, we look down. And that should give us an area. I don't have my z-chart handy, but let me grab one quick. So if you look in your z-chart, look to 0.2, look over to 0.09. Looks to me like that comes out to 0.1141. That sound right? Okay, 0.1141. Is that my answer? No, not my answer, because remember that this chart gives you the area to the right of the mean. So that 0.1141 is actually that area, which would also match up with this area, 0.1141. So subtract 0.1141 from 0.5, and that'll give me the area I'm looking for. Get this area here, I'm going to take 0.5, I'm going to put 3 zeros on it, minus 0.1141. That's going to give me 0.3859. Sound right? Let's check the book to make sure. That's my book says 0.386. So that's probably just, yeah, it's if you round it to be 0.386. Any questions on that? So this is from lesson 6.5, but it's actually, part A is review over 6.4. Now part B is where it's a little bit different, because in part B, it says if we sample 100 teachers, teacher salaries, what is the probability that the sample mean is less than 500 or 50,000? So this time, we still have a bell-shaped distribution, but this time we're trying to figure out if the mean of 100 teachers' salaries is less than 50,000. Now, do you think this data will be more scrunched towards the mean or more spread out? Right. If you're sampling 100 teacher salaries, you're not going to have any real high or real low salaries because they're all averaged in with 99 other teachers. So the data is going to be more scrunched towards the mean. Okay? The distribution would probably look more like that. The data will be scrunched towards the middle more, not as spread out. And we're going to use, so this time, since we're talking about this being an average of 100 teacher salaries, we're going to use a different formula. We're going to use this formula here, x bar instead of x. So when you find your z-score, you're still going to use 50,000, but now realizing that represents the average of 100 teachers, not one teacher's salary. Subtract the mean, which is still going to be $52,174. Remember that our mean will equal the mean of the sample means. Those are going to be the same, according to the central limit there. And then you're going to divide by, instead of dividing by the standard deviation, you're going to divide by the standard error of the mean, which that formula is right here. So I'm going to divide by 7,500, which is the population standard deviation, divided by the square root of 100. Again, if you type it in your calculator, if you do it all at once, type it in all at once, you're going to have to make sure you put parentheses here and around the 100 and also around the denominator. So if you do that, looks to me like I have that as coming out as negative 2.9. Okay? So z-score, negative 2.9. So notice that's a lot different than a z-score of negative 0.29. Okay? So my z-score comes out of negative 2.9, meaning that an average salary of 50,000 out of 100 teachers, that would be 2.9 standard deviations below the mean. So now I go ahead and look that up. Look up 2.9 and 0.0 up here. Come over, come down. What does that give you for an area? 0.4981. So that tells me that this area in here is 0.4981, which means the area to the left of the mean would also be 0.4981. And I'm trying to find the area less than $50,000, so I would subtract from 0.5 to get this answer here. So I do 0.5000 minus 0.4981, 0.0019. Big difference in answers, isn't there? Look at the two answers. Is it more likely to find an individual teacher with a salary less than 50,000, or to find a group of 100 with an average salary of? Individual. Yeah, it's not that unusual. About a 38% chance that you could find an individual teacher. If you randomly pick the teacher, it's about a 38% chance you're going to find one with less than $50,000 salary. But if you go out and survey 100 teachers, it's pretty unlikely that their average salary is going to be less than 50,000. Only a 19 out of 10,000 chance. This is your answer for part B.